Hello everyone and welcome back to another video. My name is Dylan and in this one we are going to be taking a deep dive into an entire past paper. It's a reasoning paper, it's from 2017 and I'm going to show you how to answer every single question with you practicing along as we go. So as always it looks like this in the front, you can see it's from 2017, first name, middle name, blah blah blah. We don't need to do that because we're just going through this past test, all available on the government website. All the instructions are the same as always. Let's dive into question 1. William asked the children in year 2 and year 6 if they walk to school. This graph shows the results. You can see here as well, this is a key. It's not labelled as saying key, but it is a key. Dark shading here, walk to school, light shading, don't. Altogether, how many children don't walk to school? Well, this is where we need to know. The key is showing us the light grey is what we need. So in year 2, it's the light grey bar that we go over very carefully to the edge to figure out how many children don't walk in year 2. It's right in between 100 and 120, so this is going to be 110. Important now that we can read off the chart. 110 in year 2. How many in year 6? Well, we've got more to get through, but we've still got to be really careful. We'd be using a ruler in real life to get across. And of course, it's in the middle again, between 80 and 100. That's going to give us 90. So altogether, 110 plus 90 is 200 children do not walk to school. How many more year 6 children than year 2 children do walk to school? So this time we need to still use both of the charts, but this time we're using year 2 who do walk to school, which is dark coloured shading in from our key at the top. So year 2, we go across again. Of course, it's in the middle. So 70 children walk to school in year 2, and in year 6, oh, luckily for us, it's not in between. We just read off 120 children walk to school in year 6. So how many more children in year 6 walk to school? So it's 120 children in year 6. We take away the 70 children in year 2, and we're left with just 50. Very often in these types of questions, where we have lots of information going on, you'll see it split into 2 like this, where you use lots of different parts of the graph. We actually used every single part of the graph in here in order to answer all of these questions. Let's move on to question 2. Circle the number that is 10 times greater than 907. This is a question that could be on your arithmetic paper. And this is how we make it harder in reasoning. Because in the arithmetic, we'd simply write 10 times greater than 907. We could see this very easily on the arithmetic paper, and it would probably be simpler for you to solve. Here, we're testing that we can read the question properly and know that 907, like this, is written 907. It's just testing your ability to read numbers as well. So 907 times 10, we're going to shift all of the digits up one place, 907, with a placeholder at the end. The answer is 9,070, so we're going to circle that one. Question 3, write the missing numbers to make this multiplication grid correct. You'll notice, yes, it's a multiplication grid, but it's not the answers that we're missing. It's actually the numbers we're multiplying together at the top. So we're given a 9, so we know that anything across this row here has been multiplied by 9 and something else above it. So how do I make 63? By doing 9 times what is 63? And this is where your knowledge of times tables comes in. I know there are 7 9s in 63, so I can put a 7 up there. Let's keep going across just to make sure we get all of these answers in a row. 9s into 54. Well, that's 6 9s in 54. And once we've filled out the top 2 here, notice all of this is just for 1 mark, by the way. So if we stopped here, we wouldn't be getting anything. We'd be getting 0. Even though we've done all this work, we have to remember this box here. So 56, what do we multiply by 56? Multiply by 7 to get 56. The answer is 8. And then we can just check that because we should have 48 being the answer when we do 8 multiplied by 6, which is, and this right here is the only way to get 1 mark if you've got all 3 numbers. And notice how it chose the 9s, the 8s, the 7s and the 6s. Probably the trickiest of the times tables, particularly the 7s, often catch a lot of people out. Question 4. This table shows the heights of 3 mountains. Mount Everest, Mount Kilimanjaro and Ben Nevis. We've got the height there in meters. How much higher is Mount Everest? So we want this one, Mount Everest, 8,848 meters. How much higher is that than the combined? And here's what we're testing here, vocabulary knowledge. What do we do when we combine things? We add them. Combined height of the other 2 mountains. So Kilimanjaro and Mount Nevis, we need to add these together. So let's do that first, shall we? I've written down 8,848. Maybe that was premature. Maybe I could have waited. Because what I'm going to do now is add together 5895, which is Kilimanjaro, And I want the combined height with Ben Nevis. So that's 1, 3, 4, 4. So 5, 8, 9, 5 plus 1, 3, 4, 4. Let's add those. 5 plus 4 is 9. 9 plus 4 is 13. 8 plus 3 is 11. Plus 1 is 12. 5 plus 1 is 6. Plus 1 is 7. So we have 7,239. But the question said, how much higher is Mount Everest? And notice it's a 2-mark question. We're going to have to do multiple steps here. So far, we've only done one. So then we're going to take the height of Mount Everest, which is extremely tall, 8848, and we're going to take away the combined height that we just calculated to find the difference, to find how much taller Mount Everest is than the combined height. 8 take away 9. Well, we're going to exchange here. This turns into a 3, and now I've got 18. So I have 9 in the ones. 3 take away 3 is nothing. 8 take away 2 is 6. 8 take away 7 is 1. So the answer is 1,609 meters. 2-mark question, so we should always be thinking, what do I need to do here other than just one step? And those are the 2 steps. Question 5, complete this table with the missing numbers. 1 row has been done for you. So 3,500 is the number. What is 1,000 more? That's been done, nice and straightforward. 85, well, I want to add 1,000, so the answer is 1,085. It's tricking you here because you need to remember your placeholder in the hundreds, 8 in the tens, 5 in the ones. Now it's testing, can you figure out the trap? Because here, 9,099, a lot of children would think, well, I just do 1,000 more, right? Because the question's 1,000 more. No, this number here is already 1,000 more. So we have to do the inverse to work backwards and take off 1,000. That leaves us with 8,099. Same again here, 1,000 more is already been applied to 15,250. So we go backwards and we have 14,250. Some of you might be thinking, do I need to put the comma in? You can, you don't have to. Make sure it's really clear it is a comma though, and not a decimal, because that would be very frustrating. Write these numbers in order of size from the smallest. Well, whenever we compare numbers, we start with the place value that is furthest along in terms of the biggest end. So in these numbers, they're decimals. We're going to look at the ones value, and we have zeros and ones. So we have 2 0 values, 0 point, and we have 2 1 values, 1 point. So let's dive in now into the 0 point numbers. 0 point, let's look in the 10th column. 0.9 or 0.3? Well, 0.3 is smaller because 3 is smaller than 9. And lots of you might be thinking, well, no, wait, 96 is smaller than 328, right? Well, you have to be really careful, because what you could really do here is put a placeholder in the thousandths column. And now this becomes 960. So when you're thinking of numbers like that, just be careful that you don't fall into the trap. Look at one place value column at a time. Now looking at the ones, this has 9 tenths and this has 2 tenths. So 2 tenths is smaller, even though it has hundredths and thousandths after. It doesn't matter because 9 tenths is more than 2 tenths. So there's our order right there. Excellent. In this question, we need to have pre-existing knowledge. We need to know that there are 12 months in 1 year. We need to know that there are 24 hours in 1 day, HR in 1 day. And we need to know that there are 7 days in 1 week. That's something we need to know. If we don't know it, we won't be able to solve this question. On top of that knowledge, we then need to have good times table knowledge. So how many 12s fit into 60? Well, 1 year would be 12 months. 2 years would be 24. Keep going in 12s and you end up with 5 years is 60. Then below that, how many 24s can we fit into 72? This is less about times tables, more about repeated addition. Well, if 1 day is 24 hours, 2 days are 48 hours, add another 24 on, and you get 3 days is 72 hours. And then finally, if 7 days is 1 week, how many lots of 7 fit into 84? It's another times table question, and it's 12. 12 sevens are 84, so 84 days is 12 weeks. Question 8, this is a 2-mark question, so we know we're going to have multiple steps here. At the start of June, there were 1,793 toy cars in the shop. During June, 8,728 more toy cars were delivered. So we should be thinking straight away, that's adding to the amount of cars we have. So we know that's addition. I'm just going to make a little note of that. 9,473 toy cars were sold. So that is taking away, because the shop is losing those. They are going out to customers. How many toy cars were left at the shop at the end of June? Amazing. So let's start with 1,793 and let's take into account all of the new toy cars that were delivered, which was 8,728. So let's add those up. 3 plus 8 is 11. 9 plus 1 plus 2 is 12. Cross out that 1. 7 plus 7 is 14. Plus the 1 there is 15. And then 8 plus 1 plus 1 is 10. So we end up with 10,521. But we also had some sales. So let's do the second part of this 2-mark question and take away 9,473. There's going to be a bit of exchanging here, so let's get going. We'll exchange over from the 10s to make this 11 take away 3 is 8. 1 take away 7, we need to exchange again. 11 take away 7 is 4. 4 take away 4 is nothing. And we have to exchange over here. 10 take away 9 is 1. So 1,048 toy cars were left. That looks about right because we sold more than we had delivered. So it should be less than what we started with, which it is. So I'm happy with that answer. Question 9. Tick 2 shapes that have 3/4 shaded. Now straight away you will notice this. There are no shapes with 4 equal parts in them. It doesn't exist. So this is testing our equivalent fraction knowledge as well. So 3/4 is the same as, if we multiply the top and the bottom by 2, it's the same as 6/8. And you'll notice straight away, look, this is 6/8. Awesome. What's this one? Well, this looks like it's 3 shaded out of 6. That is certainly not 3 out of 4. So it cannot be 3/4. It's 3 out of 6, not 3 out of 4. Down here, let's have a look. 1, 2, 3, 4, 5, 6, 7 out of 9. We cannot get 7 out of 9 from using 3/4. So it's definitely not that one either. And looking at this bottom one, I want you to notice something. We can count them up. That's absolutely fine. We'd end up with 12 out of 16, which we could work out is the answer. So that is actually correct. But also I want you to do this. Imagine splitting this into groups of 4. Okay. You can see here, look, 1, 2, 3 shaded out of 4 in total. We also have 3 shaded out of 4 here, 3 shaded out of 4 there, and 3 shaded out of 4 here, which again proves that it is 3/4 repeated. Or, like I said before, we could do 12 out of 16, which is equivalent to 3 out of 4 if we multiply both by 4, the numerator and the denominator. Classic question. Comes up so often. It's just simply testing, can you do rounding? But it's going to use the same number. 84,516 rounded to the nearest 10. Well, 84,500 and is it going to be 510 or 520? Well, look at the ones. It's a 6, so we're going to round up to 20. Next one, to the nearest 100. Okay, so 84,000. Is it going to be 500 or is it going to be 600? Well, look at the digit after in the 10s. It's a 1, so we're going to round down. It's going to be 500. And then finally, to the nearest 1,000, 80 what thousand? Is it going to be 4,000 or is it going to be 5,000? Well, if we look at the digit after the thousands column, in the hundreds column, we have a 5. That means we're going to round up to 85,000. That is how we answer those questions. We go along the number until we have to figure out which one we're closest to, whether it's the 10s, the hundreds, or the thousands. And we have to read the question carefully to make sure that we are in the right place. Question 11. Here's a rule for the time it takes to cook a chicken. Cooking time, 20 minutes. So this is almost like algebra here. Plus 40 minutes for each kilogram. So let's say K. So 20 minutes plus 40 times K. How many minutes will it take to cook a 3-kilogram chicken? Well, let's do the 40 times 3 first, because that's 40 minutes per kilogram. So that gives us 120 minutes. But we also cannot forget the 20 minutes at the start. So add that on too, and we get 140 minutes for a 3-kilogram chicken. What is the mass of a chicken that takes 100 minutes to cook? So in this case, we're given the answer, and let's whack in our formula. 20 plus 40K is 100. Well, let's take off the 20 off both sides. So we end up with 80 here, because remember at the end, we added 20 on at the end. Let's just take it off. So 40 lots of kilograms equals 80. Well, that K then, what number must that be? How many 40s are in 80? Well, it must be 2. A 2-kilogram chicken, 2 times 40 is 80, plus the 20. Yep, that gives me 100. So that's the answer there. That was basically algebra hidden inside of a question. Here are diagrams of some 3D shapes. Tick each shape that has the same number of faces as vertices. Faces are the flat 2D shapes that make up the 3D shape, and the vertices are what we would call colloquially the corners where the edges meet. So in a cube has 6 faces and it has 8 vertices. They do not match up. We can see here, look, 1, 2, 3, 4, and then 4 more at the bottom. And like on a dice, has 6 sides. We know it has 6 faces. A square-based pyramid, 1, 2, 3, 4, 5 vertices and 4 triangles around the side plus 1 square at the bottom. That's 5 faces. I'm going to tick this one. Has the same bases as vertices. Triangular prism. 1, 2, 3, and then 4, 5, 6 vertices. Does it have 6 faces? I don't think it does. It has 1 on this side and 1 on that side. And then 1, 2, 3 around the middle. It only has 5 faces, so I'm not going to tick that one. And a triangular base pyramid. 1, 2, 3, 4 vertices. How many faces does it have? Well, it has the triangle at the bottom and then 3 triangles, 2 at the front here and then 1 at the back. So that is 4 in total. So the pyramids had the same number of vertices as faces. Very interesting. Question 13. Ali and Jack buy some stickers. A pack of 12 stickers is $10.49 and 12 stickers are 99p each. Ali buys the pack of 12 on the deal for $10.49 and Jack buys 12 single stickers. How much more does Jack pay than Ali? Well, let's find out first how much Jack paid. We know Ali paid exactly $10.49, but for Jack, we'll have to do 99 multiplied by 12. Now, you could do any kind of long multiplication here or use your times table knowledge. I'm going to show you a shortcut. I'm going to do 100 times 12 because that's so easy. So let's say it's 1,200 pence that he spent. But I added on an extra 12. I only want 99 12s. This is 100 12s. So if I take away 12, I end up with how much he actually spent, which was 1,188 pence. Or if you want to convert it to pounds, that would be £11.88 pence. Whereas Ali spent exactly £10.49 pence. So to find how much more that Jack spent, we need to take these two values away. Let's do some exchanging here. 18 take away 9 is 9. 7 take away 4 is 3. Put a decimal place. 1 take away 0 is 1. And then we have nothing there. So the answer is £1.39. Always better to check the deals to see if you're going to be able to save some money. That's what this question proves us. Question 14. Amina planted some seeds. For every 3 seeds that Amina planted, only 2 grew. So that means out of 3, 1, 2, 3, only 2 grew. So if she managed to plant 6 seeds, that would mean 2 more grew, but 1 didn't. So for 6 seeds, she would have 4 that grew. Let's see what the question says. Altogether, 12 seeds grew. Wow. Okay. So how many seeds did she plant altogether? Well, if it's 2 grow for every 3 that we plant, if we have 12 seeds grow, how do we get from 2 to 12? Well, that's multiplying by 6. So let's do the same over here. 3 multiplied by 6 means she must have planted 18 in total. So 18 is how many she planted. That means 12 grew and then 6 didn't. And that follows our ratio that we have here. Roman numerals. At the end of a film, the year is given in Roman numerals. MMVI. What is that in figures? Well, again, much like before with the conversion facts, we need to know some facts before we can even solve it. M in Roman numerals is 1,000. So MM, that's going to give us 2,000 to start with. Then VI, well, V is 5 and I is 1. And because the I comes after the V, we just add them together, which gives us a 6. So we need to say 2,000 and 6. Be careful where you put your 6 because we need to add this on. So 2006 has 2 zeros in the middle with a 6 at the end. And that's the answer to that question. Layla completes 1.5 somersaults in a dive. How many degrees has she turned through? So 1.5 somersault. A somersault would be a full turn. And we know a full turn is 360 degrees. Then she did a half. So when she was at the top, she did another half. Well, what's half of 360? 180. And you may again know this as a fact that a straight line has an angled degree turn of 180. So in total, if it's 1, which is 360, and half, which is 80, altogether, that is 540 degrees that she has spun. Very interesting question. That's basically asking how many degrees in 1.5 turn, just in the context of a somersault. The vertices of a quadrilateral, which is a 4-sided shape, have these coordinates. One side of the quadrilateral has been drawn on the grid. Can you complete the quadrilateral? So we have here 5 across and 4 up. So we've done 5, 4. And we've got here 1 across and 5 up. So we've done 1, 5. Let's do 1 minus 3. So we start at 0 at the origin and we go across 1. And then minus 3 means we're going to go down. 1, 2, 3 is here. And I'm actually just going to plot this other one here, minus 3, 4. So we start at 0. Minus 3 is the first thing we do on the x-axis. 1, 2, 3. And then I think it was 4. Yes, so we go up 4. 1, 2, 3, 4. So it goes right there. You would be using a ruler. I'm going to do it freehand because I don't have a ruler function on my computer right now. But it will look something like that with a much neater straight line because you'll be using a ruler. So making sure, just very quickly, that we plot those points exactly right. And we can see there, looks to me as if that's a kite. Question 18. A cat sleeps for 12 hours a day. So 50% of its life is spent asleep because 12 hours a day is 12 out of 24, which is the same as 1/2. Again, which we know, fractions, decimal, percentage conversion is 50%. So what we've got here is a question of converting fractions, decimals, and percentages hidden inside of a reasoning problem. Write the missing percentage. A koala sleeps for 18 hours a day. What percentage of its life is that? Well, again, let's do the same as above. 18 over 24. Let's simplify this. Divide them by 6. We get 3 over 4. Aha, 3/4. And if you know your fractions, your decimals, your percentages, conversions, you should know that 3/4 is 75%. So we're going to put 75% in right there. Like your conversion facts before, like your Roman numerals, there are certain things you just need to know going into this test. And I would say that knowing 25%, 50%, and 75% is vital to being successful. Knowing that they are 1/4, 1/2, and 3/4. It will save you so much time and help you so much. I promise it's worth it. Amina posts 3 large letters. The postage costs the same for each letter. She pays with a £20 note and she gets change of $14.96. What is the cost of posting 1 letter? Well, the first thing we need to figure out how much it cost for the 3 letters. So let's take her £20 note, which I'm going to write as 20.00, and take away her change because this will show me exactly how much it cost her. So we're going to do a lot of exchanging here. Another way we could do this would be with a number line, jumping up from $14.96. I much prefer this method because it's quicker and it's cleaner, going up to £20. Let me show you what I mean. $14.96, well, jumping up to the next pound, whole pound is £15, which would be 4 pence. And then going from there, 15 to £20 is just £5. Notice how much easier that is than doing all of this, exchanging 10 and then getting 9 and then exchanging and getting 9 and then exchanging and getting 10. There's so much room for error there, but we'd end up with the same answer, which is £5 and 4 pence. £5 and 4 pence. But this is a 2-mark question, so we know we're not going to stop there. We've only done one thing. Now we need to figure out the cost of posting 1 letter. Well, she posted 3 rather, and they cost the same. So we're going to take our 5.04 and we're going to divide that by 3. How many 3s in 5? 1 3 and 5 with 2 left over. How many 3s in 20? 6 3s in 20, which is 18 with 2 left over. How many 3s in 24? That's 8. And we get £1.68 per letter. If you had time at the end of the test, what you could do there is 168 times 3. See if you can add on 14.96 and it should come to exactly £20. Adam says 0.25 is smaller than 2/5. Explain why he is correct. Well, let's take a look at this because again, the trap here is you see a 2 and a 5, you 2 and a 5 and you say it's equal. No, Adam is correct here because 0.25 is equivalent to 1/4, we could say. And then we could say, and 1/4 is smaller than 2/5. And we could prove this. We could multiply this side out by 5 and we could get 5 out of 20. And we could say that is clearly smaller, multiplying this side out by 4, than 8 out of 20. We could use maths to prove it. We could do a number of ways. We could be explaining using words here. You might want to change 2/5 into a decimal. You could say 2/5 is the same as 4/10, and 4/10 is 0.4. Okay, so you could be showing it this way as well. 2/5 is 4/10 is 0.4, and then you could very clearly show that 0.25 is smaller than 0.4. However you do it, you're going to prove it and then explain it. You can write a sentence as well underneath to make sure you get the mark. Question 21. On a map, 1 centimeter represents 20 kilometers. And you can see here, every centimeter on the map is actually worth 20 kilometers. The distance between 2 cities is 250 kilometers. On the map, what is the distance between the 2 cities? Well, we know, for example, that for it to be 100 kilometers, that's going to be 1, 2, 3, 4, 5 centimeters. Cool. So for 200 kilometers, we're going to double that. That means it's 10 centimeters. Nice. But I want 250. So how can I work out what 50 kilometers would be? Well, if I have 100 kilometers, I can half it. What's half of 5? That's 2.5 or 2.5 centimeters. So now I've built up this kind of pad of knowledge that I've got here. I can say, okay, so for 250, I can take 200 kilometers, which is 10 centimeters. And I can take 50 kilometers, which is 2.5 centimeters. And I can add them up, and I get 12.5 centimeters. On the map, that's how far away they would be. And in real life, it's 250 kilometers. Question 22. Here are two similar right-angled triangles. When we say similar, they can be different sized, but they are going to be the same angles inside, even though the lengths are different. Write the ratio of side A to side B. What we're asking here is, how many times, if side A is worth 1, so this line here is worth just 1, how many of those 1 can we fit in to side B? And that would give us our ratio. So let's start off with a simple one, which would go to here. That's 1. Notice I've gone 2 across, like here, and 1 up. Let's go 2 across and 1 up again. And this time I've got 2. Let's do it again. 2 across and 1 up. Now I can fit 3 in. And you probably know where this is going. One last one. 2 across and 1 up. 4. So I can fit 1, 2, 3, 4 on my triangle B. So the ratio from A being 1 means that B is 4 times bigger. It's the same for this side and it's the same for that side. You can test it out if you would like. The ratio there is 1 side A, and then that would be 4 of them fitting into side B. Question 23. In this circle, 1/4 and 1/6 are shaded. What fraction of the whole circle is not shaded? So there's a very simple way of going about this. Okay, a couple of things we could do. We could notice that 1/4 is not shaded and 2/6, and we could work from there. Or we can work with what we've got, which is 1/4 and 1/6. Here's what I'm going to do. I want to use the unshaded area, which I know is 1/4 and 2/6. So what this question is actually asking me to do is to add together 1/4 with 2/6. This is something that you could get on an arithmetic paper. It's just been hidden inside of a tricky question. Do you know what I can also do? I know that 2/6 is the same as 1/3. So I'm actually doing 1/4 plus 1/3. That's what this question is asking me to do. So let's multiply out this side by 3, and I get 3 out of 12 because I want the denominators to be the same. Multiply this fraction out by 4 on the top and the bottom, I get 4 out of 12. That leaves me with a total of, not 4 out of 7, no, 4 out of 12. I was actually writing 7 already for my numerator. 7/12, therefore, is not shaded. And that's the important thing there, not shaded. And because I did this part first, I managed to bypass that part of the question because I read it and I understood it early. 7/12 right there is the answer. And that's the end of that paper. Guys, I hope you found that useful. It's always good to go back in past papers and practice questions and practice and practice and practice. And I will see you again next time for another walkthrough of a test.